The Kepler archive was never built to search for aliens. It was built to catch a shadow, a planet crossing its star. But somewhere in that decade of light curves sits an unspoken assumption that if a civilization were out there, our instruments would be pointed at the right kind of physics to notice it. That assumption is the trap. Modern SETI runs on 3 main channels: narrow-band radio, tuned to frequencies that don't occur in nature; optical pulses, fast enough to stand out from starlight; and infrared excess, heat that shouldn't be there, the kind you'd expect from a civilization using energy on a planetary or stellar scale. Each method works. Each one also assumes the searcher would build technology we'd recognize. Take the Dyson sphere search. The logic is simple. A civilization capturing a star's full output would radiate the waste heat in the infrared, since no engine is perfectly efficient. Surveys have scanned hundreds of thousands of stars for exactly that excess. A few candidates showed up. Every one, so far, turned out to have a natural explanation. Dust, a background galaxy, a cooler companion star. The absence isn't nothing, but it carries a hidden condition. It assumes an advanced civilization still needs a heat sink the size of a solar system, a species with different thermodynamics, or one that doesn't harvest stellar energy at planetary scale, would leave no excess to find. The search measures a choice, not a capability. Optical SETI has its own blind spot. It hunts for laser pulses briefer than a nanosecond, brighter for an instant than the host star. The technique is real and sensitive, but it depends on timing, on pointing the right telescope at the right patch of sky during the exact second a pulse arrives. Most of the sky, most of the time, goes unwatched. A signal could have already come and gone. The silence in these surveys measures our scheduling as much as it measures the galaxy. Then there's atmospheric chemistry, the search for industrial gases in an exoplanet spectrum. A transit spectrum isn't a photograph. It's a list of missing colors, wavelengths absorbed by specific molecules. In principle, a gas like a synthetic refrigerant would leave an unmistakable line, one with no known natural source. In practice, the spectra are noisy, the lines overlap, and a false positive is easy to get from ordinary geology or an unresolved companion star. Even a clean detection wouldn't settle the case. The gas would only prove that whoever built it made industrial chemistry the same way we do. A civilization using different catalysts, different materials, different physics entirely, would leave a spectrum that looks like nothing at all. Not silence from absence, silence from mismatch. That changes how you should think about the Fermi paradox. The usual question is, if they exist, why haven't we found them? A sharper question is, would we recognize them if we did? An old enough civilization might have moved past radio centuries ago, the same way we moved past smoke signals. It might not generate detectable waste heat if it never scaled energy use the way our models assume. It might use materials or engineering that leave no chemical fingerprint our spectrometers are calibrated to expect. The dangerous move here is to call any of this proof of something. It isn't. The data doesn't show emptiness. It shows the limit of what current instruments are built to notice. A stronger claim, in either direction, would need a method that doesn't start from human engineering as the default template. That method doesn't fully exist yet. Some researchers are testing statistical approaches, looking for structure in noise rather than specific signal shapes, or searching for anomalies without deciding in advance what an anomaly should look like. It's early and uncertain. It doesn't promise a detection. It promises a wider net. The next telescopes will help, but only at the edges. Wider infrared coverage, better spectral resolution, longer optical monitoring baselines. None of it solves the deeper problem. Every search is still a search for something we already know how to imagine. The sky, right now, is quiet in every channel we've built to listen. That quiet might describe them, or it might only describe us, the shape of our own instruments, projected outward and mistaken for the shape of the universe. Subscribe if you want the next file followed when the method changes.